Okay, so welcome everybody. As I say, this is about how we can boost our immune health and support our immune system to fight off things like bugs and colds and flus and things and keep ourselves healthy. And I will say that this is an incredibly complex topic. I'm not medically qualified. This is a very basic general overview of the immune system, how it works, and then some natural ways that we can support our body to be as healthy as possible. So this is me, just to introduce myself. I'm Deborah Bircham and I'm a naturopathic nutrition and health coach. And I also do hypnotherapy and mindfulness and eye movement therapy as well. So I'm registered with all of these various bodies, but I have mast cell activation syndrome myself and dysautonomia and pain and Lyme disease. So I also bring that personal lived experience to this, and a lot of this is based on my own understanding of what I do to help myself and what I've learned on my own health journey, which is why I hope that it will be useful for you. So thinking really about how healthy is your immune system. If you're catching lots of colds, if you're always the one that gets everything that's going around, then your immune system is not as active and fighting those things off as well as it should be. Similarly, if you've got lots of fungal infections, if you've got candida, if you've got fungal nails, if you don't heal from wounds quickly, if your wounds don't heal properly, because it's the immune system that triggers that response of wound healing. So if we have wounds that don't heal very well, if we bruise easily and we get lots of bruising for no real reason, and if we have a lot of inflammation, which with MCAS we tend to have, that is a sign that the immune system is struggling, that it's imbalanced and it's not working terribly well and it's under strain. And so we're going to look a little bit tonight at why that can be. And in order to understand how to support the immune system, we need to have, as I say, a really basic understanding. And this is, as I say, I'm not an immunologist, this is really basic, but we need to have a bit of an understanding of how our immune system is working and what's going on in order to be able to see what's happening. So basically, I'm just going to do a little bit of a mini introduction to the immune system. And there's two parts of our immune system. We call it the immune system, but actually there's two parts. There's the innate part, the innate immune system, and we're born with that. We have it from birth. And we literally can't survive without that. It protects us from birth, from everything that might kill us in the world. And it's non-specific, so it attacks absolutely anything in the body that's not supposed to be there, anything that it perceives to be a threat. It attacks through various different mechanisms. There's various different cells involved that do different things. And one of the primary mechanisms that it uses is to create inflammation. So it's trying to kind of burn out the nastiness by creating this inflammation. And we all know and love our mast cells, which are part of the innate immune system. So they're one of those cells that is involved in that. And then around about 2 years of age, we develop the adaptive immune system, which is the second part. And that develops as we're exposed to germs in our environment as children. Once we're born, we start to become exposed to all sorts of things. And the adaptive immune system develops. It starts to learn what's friendly and what's not friendly. And we could survive if we lost our adaptive immune system. The innate system, we can't live without it, but the adaptive, we can survive without it. And that is very specific, unlike the innate, which is non-specific, it just attacks and kills everything. The adaptive immune system is making antibodies for specific antigens, which are the invaders, the foreigners that it identifies. It makes a specific antibody, so it only attacks that one specific thing. So those are the two branches of our immune system. And the innate immune system, I mentioned, there's various different cells. So there's neutrophils, and they engulf the foreign cells and they sort of dissolve them with nasty chemicals. So they eat them and they kill the cells, but it's a bit like a sort of suicide mission because they kill themselves as well in that process. And then the macrophages, which literally translates as big eaters, they come along a bit like Pac-Man there on the screen. They literally gobble up the neutrophils and all the debris that has been created from the neutrophils, killing all of the nasties. So they eat everything that is left. And then we have natural killer cells, and they patrol around in our bodies and kill off anything that is diseased, anything that's been infected, and also anything that's mutated or cancerous or precancerous. Any cells in our body that don't look like they should do and are not healthy, our natural killer cells are supposed to get rid of those. And then our mast cells, as we mentioned, they're also part of the innate immune system, and they release inflammation and signaling chemicals, as we know, the cytokines that they release that, communicate with all the other parts of the immune cells. And then the adaptive immune system, as I said, it's specific. It creates specific antibodies, and the primary part are the lymphocytes, the white blood cells. And there's two different types of those. T cells, which mature in the thymus, and that's why they're called T cells. And they attack and destroy the nasty foreign particles that have become identified in the body. And as part of that, they trigger the B cells to produce the antibodies. And the B cells are produced in the bone marrow, which is why they're called B cells. And when they've been triggered by the T cells, they then produce the antibodies, which creates this kind of memory that enables us to remember things that we've encountered before, and we have then an antibody to deal with that. So T cells, as I said, mature in the thymus, and it depends on what they're exposed to. As they're maturing, they mature into one of four types of T helper cells, or TH cells. There are other types, but there's four main ones. So if you've got TH1 cells, they fight bacterial or viral infections. If you've got TH2 cells, they fight parasites, but also are involved in the allergy mechanisms. And the TH2 system is what signals and controls our mast cells. And then if you've got TH17 cells being made, that's kind of an autoimmune pathway. And then T regulatory cells are produced with all these other types, and their job is to try and calm down the immune system so it doesn't go completely crazy and start, doing too much attacking. So we're always producing the T reg cells to try and dampen it down a bit, so there's a balance, just enough killing but not too much. And the T reg's job is to keep the immune system in balance. So the adaptive and the immune systems work together. So when we get a germ entering the innate immune cells, like those macrophages and the neutrophils, they go straight in and they attack the germs right away. And then the innate system, like the mast cells, they send out those signals, the cytokines, the alarm that goes out to say we're under attack here. And then the macrophages do this amazing thing where they've gobbled up all of the nasty pathogens, but they stick a bit of the antigen, a bit of the body, if you like, the protein of the pathogen onto the surface of their bodies and travel to the lymph nodes, which is where our T cells are living. And inside the lymph nodes, they show the antigen to the T cells, and then the T cells signal to the B cells what type of antibody to make. So that's the adaptive process that's happening there, where they're being told what's invaded, what are we dealing with here, and have we got a memory of this before? Is it something we've seen before and we've got some antibodies that are all ready to attack it, or is this something new that we've not seen before and we need to make antibodies? So this is how the two systems are talking to one another. And then the adaptive immune system creates that memory after it's all, died down. We then have that memory of antibodies that live in our body forever. In case we come across that particular nasty pathogen again, we'll already have the antibody made for it. So that's a very brief, very, very basic description of how our immune system works and some of the cells that are involved in that. But we need to think about what weakens the immune system. Why is it that our immune system doesn't always work as it should do? Because it's meant to be. If the body is functioning really well, our immune system is incredible, and it, does all of that amazing stuff and protects us. So why does it go awry sometimes? What weakens it? And all of these things put a strain on the immune system. So viral infection load, bacterial infection load, if we're exposed to mold, if we're exposed to a lot of toxins and nasty chemicals, If our gut microbiome is out of whack and we've got dysbiosis, if we've got constant inflammation happening, if we've got autoimmunity happening, if we're deficient in nutrients, because the immune system, needs nutrients to do all of that. It doesn't fuel itself. It needs to use nutrients to make all of that happen. So if we're deficient in nutrients, that can affect it. And also stress. Stress has an enormous impact on our immune system and whether our immune cells are functioning properly. And our bodies are amazing and they're incredibly resilient and adaptive. And if we have one or two of these, our immune system kind of just goes, whoa, that was a bit hard work, but I'm fighting on. But if we get a combination of all of these things happening to us, one after another, bang, 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 blow after blow after blow. And if we've got all of these things happening, so we've got a viral infection load that's lurking, we've got bacterial infections that are lurking, we've got, some kind of dysbiosis in our gut, and then we get a load of stress as well. Something very stressful happens, a redundancy or something, and then our immune system can say, whoa, that's it, I just can't cope with this now. And that's when we start seeing our immune system not fighting things off as effectively and not working as effectively. So looking a little bit closer at some of those now then, so viral infections, Epstein-Barr virus, glandular fever, that, lurks in our body for, forever after we've had it. It's always there and our immune system is always having to just do a little bit of work to keep that under control. The herpes virus, the chickenpox virus, the hepatitis virus, cytomegalovirus, and now COVID, of course, we can have quite a large viral load. And the human microbiome, we talk about the gut microbiome, but it's everywhere really in our whole body, is actually not just bacteria, it's viruses and fungal infections as well, fungal organisms as well. So we have this constant load of viruses in our body, and usually they just live there, in kind of synergy with us, and they're not a threat because the immune system keeps them under control. But if they become out of control, if the immune system is not controlling them, they then can trigger illness. And research is, increasingly linking illnesses like cancer and multiple sclerosis. There are researchers that believe that there is a viral component to a lot of chronic illnesses that are going on, and that these viruses are triggering an immune imbalance in our body. And when we become stressed or we have, too much other load, these viruses can be reactivated. And the more viruses we've got lurking, the more viruses we've come into contact with, the more strain it is on our immune system. So that's one thing that can affect how well our immune system is working. And then bacterial infections. Some bacterial infections interact with our immune system and weaken it or suppress it. For example, the Lyme disease bacteria, Borrelia burgdorferi. One study showed that when we're exposed to that Lyme bacteria, it triggers abnormalities in the lymph nodes and stops our adaptive immune response. So remember, those macrophages take the antigens to the lymph nodes and show it to the B and the T cells in the lymph nodes. That's where they're living. And that's what creates that adaptive immune response. And this study showed that for months after infection with Borrelia, the lymph tissues weren't producing B cells and they weren't able to produce the antibody response in response to an infection. So basically, the bacteria is stopping our immune system from being able to create that memory, that antibody that enables it to protect itself or protect us from that infection. So they found that even after a Borrelia burgdorferi infection, the immune system wasn't even able to respond to a flu infection when the person was exposed to flu. So it's not just, doesn't just affect how we respond to Borrelia itself, it is affecting how our immune system is able to create antibodies to all infections. And so these bacterial infections, the studies are showing that they can weaken our immune system. And also there's a process called molecular mimicry where some bacterial infections can get into our tissues, and then our immune system gets confused about, which is the infection and which is our self tissue, and that can trigger autoimmunity. And there's a lot of research about that as well. So viral infections and bacterial infections can change the way our immune system works. Mold infections also, or mold exposures. So when we are exposed to mold, it dysregulates our immune system function, and the mycotoxins released by mold spores really impact our immune system. They dysregulate our innate immune response, and they suppress the Th1 response. So we can't, if you remember, that Th1 response is the way we fight viral and bacterial infections, and mold mycotoxins kind of switch that off and stop us from being able to fight viruses and bacterial infections. But it creates an imbalance. So we have not enough Th1, but too much of the Th2 and the Th17, which are those inflammatory mast cell activation syndrome and autoimmune pathways. So we end up with too much of that activity and not enough of the Th1. And my mold produces a type of toxin called gliotoxins particularly, and the research is showing that they inactivate the innate immune system and stop it from being able to do that initial fight back. And there's a very complicated medical terminology at the bottom here from this paper, which just explains exactly what's going on there. So the gliotoxin inhibits production of the messenger leukotriene B4 in neutrophilic granulocytes by switching off the enzyme LTA4 hydrolase. So basically that interrupts the communication between the immune cells. We saw in those earlier slides how it's critical that our immune system is constantly communicating, the cells are communicating, and basically by switching off that enzyme, it's interrupting that communication and preventing our immune system from swinging into a defense. And as a result of that, of course, it means that the spores of the mold can get into our bodies and infiltrate our tissues and organs without any impediment. There's no army there to fight them, and that's of course why they do it. They disable our defense mechanism on purpose so that they can live. And that's one way that some mold species affect our immune system. And then toxin exposures, you know, these chemicals that we're exposed to on a daily basis, BPA in plastics, phthalates, parabens. If you look in your toiletries, in your bathroom cabinet, you may find that many of your toiletries and your cleaning products contain these chemicals, and they've all been found to affect the way our immune system is operating by altering the levels of hormones that regulate the way our immune system grows, particularly in the thymus, as we talked about the Th cells, the T cells in the thymus, or the spleen. That's another seat of an organ that's a key part of our immune system. And these chemicals affect our hormones and they affect the way those organs are working. So when we're prolonged exposure, which we have on a daily basis to these things in our environment, they predispose us to develop allergies or inflammation and autoimmune disease by upregulating our immune system. So some of those chemicals are immunostimulants, so they create too much activity. And these PFAs, puffers, per and polyfluoroalkyl substances, they are what create non-stick coating in pans. So if any of you are using non-stick pans, it's probably not a good idea to do that. And also waterproofing on fabrics. They're known as forever chemicals, and once they have entered the body, they stay in the body. They're called forever chemicals because they stay in us and they stay in our environment, and we can't break them down. They don't break down. And there are studies that show that they are, you know, potentially involved in affecting our immune function. And we are exposed to these chemicals, you know, from birth and even in utero, because our mothers are you know, exposed to these chemicals, and they're getting into our babies and we're born with them, and so they affect us. And there's been studies that show that babies who have been exposed to a lot of these chemicals don't produce antibodies as well when they're vaccinated, so they don't really make that memory that protects them after a vaccine. So toxin exposure is something that's really, you know, it's not often thought about as affecting our immune system, but it's something that we all really need to be aware of and thinking about, because it does impact how well we're able to fight off bacteria and viral infections. And then gut dysbiosis, we mentioned this gut microbiome. So 70% of our immune system is living in our gut and all around the outside of our gut. So if we want the immune system to work well, we have to have a healthy gut. And in the gut microbiome, the immune cells are actually being told what to do by the microbiome in, the organisms that are living in our microbiome. They're signaling to our immune cells and telling our immune cells to produce antiviral proteins, for example. We actually, they're controlling us a little bit. They're telling us what to do. And they also teach our T cells how to distinguish between things that are good and, that are self. And so, technically we don't then develop autoimmunity, and how to recognize foreign cells. Our gut microbiome teaches our immune system how to work properly. So we need that gut microbiome to be working and to be correctly functioning in order for our immune system to learn how to work properly. And also, our gut microbiome produces this short chain fatty acid called butyrate, which has lots of functions in the body, but one of the functions is that it interacts with the immune system and helps to calm down the immune system and calm down inflammation. So again, if we haven't got the gut microbiome producing butyrate, we can get too much inflammation going on. So dysbiosis in the gut, the imbalance of bacteria and not having the right bacteria and organisms in your gut can cause the immune system to function abnormally, and that's being understood now to be a primary factor in lots of health conditions, particularly autoimmune disorders, but also allergies and mast cell activation syndrome, very much connected with how our gut is working, affecting how our mast cells are working, because our mast cells line the gut. The gut is lined with mast cells. And so it's primarily the mast cells that are doing this interaction with the gut microbiome. And then I mentioned nutrient deficiency. So the immune system is incredibly expensive for the body to run in terms of nutrients. We need a lot of energy to create these immune responses, and particularly the inflammation and the production of antibodies. We require certain nutrients to be able to do that. And if we're deficient, if we're not eating enough of them, we're not going to be able to mount that immune response. So protein is one of the essential factors that is required for immune function. And some, studies show that even a subclinical deficiency, so, your tests from the doctors might come back and say, yeah, you've got enough protein, but actually, even if it's subclinical, it affects the way that our immune system can respond and leads to an increased risk of infection. So we need, more than just the minimum levels of protein. We need good amounts of protein. And vitamin D, again, is another one that's often talked about as being, essential for immune function, because it has a role in both the innate and the adaptive immune responses. And when we're deficient, we have a much greater risk of infections and also of autoimmunity. So type 1 diabetes, multiple sclerosis, lupus, inflammatory bowel disease, rheumatoid arthritis, all of these things linked to potentially deficiencies in vitamin D because of the way that impacts on how our immune system is working. So I can't go into all of the nutrients tonight, but some of the other nutrients that we really need to be making sure we're getting to support our immune health are essential fatty acids like omega-3s, vitamin A, vitamin E, vitamin C, B vitamins, and zinc and iron. So really the vitamins and the minerals here are critical. Our immune system is gobbling up vitamins and minerals in order to do its function. So making sure we're getting plenty of all of those is important for our immunity. And then stress, I mentioned that stress has a massive effect on our immune system. So when we're in that fight or flight stress state, we're releasing the stress hormone cortisol. And one of the functions of cortisol is to switch off our immune system, because I mentioned that the immune system is really expensive in terms of energy and nutrients. And if we're in life danger, if we've got to run away from a tiger or fight to save our lives, we need all our energy in that moment for running or fighting. And so the immune system, whether we got some infection, is really a secondary concern at that point. So the immune system gets switched off so that all of the energy and nutrients can be diverted to our muscles to enable us to run or to fight. But obviously we're not in life threat from a saber-toothed tiger, but we are feeling stressed and our immune system is still being switched off because that's how our body still works. So we're producing this high level of cortisol all the time when we're stressed, and it's constantly switching off our immune system. And also it's important to recognize that all sorts of things are recognized as stressors on the body, including exercise. That affects our immune system, and it creates our sort of dysregulated immune system where we get inflammation going that's not being switched off. And that's the effect of chronic exposure to cortisol. And it's also worth noting here that trauma, adverse childhood events, is highly correlated with the development of autoimmune diseases for this very reason. So people that had more than 2 adverse traumatic experiences when they were children were at 70% increased risk for hospitalization and 80% increased risk for autoimmune disease. And this is because this stress exposure when they were young has primed their body to be in this fight or flight and stress state, and is meaning that we're constantly producing this cortisol, which is dysregulating our immune system and causing it to do all sorts of things that it shouldn't be doing. So there are 3 ways in which we can support our immune system. And the first one is understanding our immune system, knowing what it needs and knowing how to work with it and not fighting it. The second way is to boost the immune system by consuming more of these nutrients that we need and giving it things that help it, and then supporting the immune system. So there are some herbs and plants and other substances that help the immune system to do its job. So some of them have antimicrobial and antiviral properties. So we can take those and it kills off some of that bacterial load, some of that viral load, some of the fungal load, takes some of the pressure off our immune system. So the immune system can go, oh, thank goodness, I haven't got quite so many battles to fight because we've taken something that kills the viruses for us. So we're going to look at each of those in turn now. So understanding the immune system. So the more exposure we get to bacteria and foreign cells when we're children, the better trained our immune system is to destroy harmful bacteria, but also to understand what is safe and what's not harmful. So we're not producing unnecessary reactions like allergies and inflammation. So we can begin from a very early age to shape our immune system by doing the right thing and understanding how it works. And the other thing to understand is that a strong immune response to a virus is a good thing. So when you get a cold or a flu and you feel absolutely rubbish and your temperature goes up and you're sneezing and you're coughing and you're full of mucus and you feel absolutely dreadful and all you can do is sleep and you don't want to do anything, that is a good thing. And we have this kind of wrong idea in our society that that's to be avoided at all costs, and we just want to push through and, take something to switch all that off, because the body is actually, that is what the body is trying to do. That is your immune system in action, trying to save you from a pathogen. So feeling really dreadfully ill is your body's way of forcing you to lie down, because your immune system is needing all of your energy and all of your nutrients to do that fighting. And we try and push through and try and keep going to work because it's expected of us. But actually, that means that the immune system is not getting all of the energy and nutrients that it needs to do a good job. And it's trying desperately to force you to lie down and go to sleep so that it can have the resources that it needs all to itself. So when we feel poorly, it's important to give into it and lie down and rest, because you're helping your immune system. And similarly, when your glands are up and your lymph nodes are swollen all in your neck and you're under your arms, that's where your immune system is working. It's a sign that those B cells and T cells are activating in your lymphatic system and fighting an infection. So we need to allow that to happen. We need to notice that and think, oh, this is a sign that my body is fighting something. My immune system is on. I need to swing into action here to support my immune system and not try and fight it. So when we're sneezing and coughing and producing mucus, that's your immune system doing that on purpose as a mechanism to try and mechanically expel the virus from our body. And it should be encouraged and supported. We want to steam with, hot steam, so that we can encourage that mucus production and you know, help the immune system to get it out. We don't want to be suppressing that. Again, a high temperature is a good thing. I know it doesn't feel very nice, but there's a reason for that, because the body wants us to lie down. But the immune system is deliberately increasing your body temperature to try and kill the pathogen, because pathogens can't survive in higher temperatures. So our immune system is deliberately increasing our body temperature to kill the pathogen. So a fever is only really dangerous if it goes above 39.5 degrees. Above 40 degrees is dangerous. So then we need to be seeking some medical help. But between 37 and 39 degrees, the body's doing that on purpose. It's increasing the body temperature to that on purpose to try and kill the infections, because they can't survive in those temperatures. And we tend to, you know, bung paracetamol down and try and cool our temperature down, lower our temperature, and, you know, keep going and dry up. You know, you see the adverts, don't you, on the telly for dry up a cold. It's the worst thing you can do, because you're actually fighting against your immune system. We're supposed to be on the same team here. You're actually helping the pathogens by doing that. So we need to support our immune system. We need to understand what it's doing, understand how it's working, and support it to do its job. So when you have a virus, the things to do to support your immune system are allowing a fever to run its course unless it gets above that sort of 39.5 degrees. Obviously monitor it, but if it's just, you know, you've got a bit of a temperature, that's a good thing. Allow that to happen. Drink plenty of fluid. Hydration is absolutely essential to help the immune system flush everything out and produce all of that mucus. So herbal teas are a really good choice, and there are some good ones. Obviously with MCAS, we need to make sure with all of these things that I'm suggesting, it just because they're natural doesn't mean that they're not going to trigger a reaction for us. So we need to experiment with our own, you know, responses and find the right thing that works for us. So you might react to ginger, for example, you might react to peppermint, but elderflower might be your thing. Find your thing that works for you. But these are some good options if you've got a fever: peppermint yarrow, elderflower, chamomile, and ginger. They all help to fight off infection and support the immune system. And if you can find one of those that you tolerate, it's a good option. Avoid eating anything that's got heavy metals in it, so things like fish, or, you know, exposing yourself to any pollutions there, or toxins like those toiletries that we talked about, and cleaning products. Any toxin exposure is going to additionally tax your immune system and give it something else to do. Drinking soups and bone broths are really helpful. Now, this is obviously, many people, you know, who haven't got MCAS can tolerate bone broths, and they help to support the immune system. When we have MCAS, bone broth can be triggering for us because it is high in histamine. Some people can still tolerate it. Just because it's high in histamine doesn't mean necessarily that you will react to it, but it is important to bear that in mind. But you can make soups and broths with just the chicken meat by boiling that up, and that's also still nutritious. Lukewarm baths to help support the fever and the temperature, promoting sweating, because that's what the body's trying to do, to make us sweat, to get the toxins and the you know, pathogens out. Don't suppress it all by taking, you know, various over-the-counter medications and things you see on the telly. And rest to conserve that energy. And then after a virus, lymphatic drainage massage is really a good idea, because all of those neutrophils and macrophages that we talked about, all of those cells that are gobbling up the nasties and dying, they clog up our lymphatic system. All of that debris, that inflammatory byproduct, just tend to kind of just get gummed up in our lymphatic system and mean that we're then not draining toxins effectively. So after we've had a virus, a gentle lymphatic drainage massage can push all of that gunk out and clear it all out, so our lymphatic system can work properly again. So that's understanding the immune system and how we can support the immune system by understanding it and working with it. And then these are some of the ways that we can boost our immune system and help it to be working better. So our gut health, I talked about how critical our gut is. So we can eat foods that contain those beneficial bacteria, and they're called probiotics, and they help support our immune system. They're the beneficial bacteria that make up our gut microbiome, and we can improve our gut microbiome. And studies show that if you've got a better microbiome with probiotics, it enhances our immune response, reduces the infection rate. For example, respiratory infections and gastric infections are reduced when we've got plenty of probiotics on board. And they also stimulate our immune cells, the macrophages and the natural killer cells. So having those healthy gut microbiome probiotics are really helpful. So again, the normal way that we would do this would be to eat fermented foods and live yogurts, kefir, sauerkraut, kombucha, things like that. For us with MCAS, that can be tricky because they can be high in histamine. So you might need to work with a practitioner who can give you some advice on how to do that without those high histamine foods, because you can take them as supplements, but you need advice from a practitioner in order to be able to do that. So consider, whether you might get some probiotics on board, because that can help a lot with supporting our gut health. Boosting the immune system, we talked about B vitamins, especially B6, folate, and B12. So they're all essential for our immune response, particularly our white blood cells and the production of antibodies. And they also help regulate the production of those cytokines, those signaling molecules. And if we don't have enough, for example, B6 deficiency has been linked to reduced productions of antibodies and cytokines, and B12 is very important in our immune cell functioning and our immune cell reproduction, if you like, proliferation. So we don't make enough immune cells if we haven't got enough B12. So we can get B12 from eating poultry like chicken and turkey, and fish and eggs and green leafy vegetables, beans, pulses, lentils, and nuts and seeds. They all contain B vitamins, so we can get, a good range of those in the diet. We want to be looking at what we're eating. And I know with MCAS, it can be difficult when we're restricted, but thinking about, you can make educated choices about what you can eat on your safe food lists. If you've got something in that range there that contains B vitamins, make sure that one of your safe foods is something that contains B vitamins, and that you're eating plenty of it to give yourself those B vitamins. Vitamin C is another one that is critical for our immune system. We always hear that, don't we? Take vitamin C, and it's true, it stimulates the activity of our white blood cells, and it's also got very strong antioxidant properties, so it protects our immune cells and keeps them healthy. And lots of foods are rich in vitamin C, and we can also take vitamin C supplements, but a lot of people with MCAS struggle with the supplements because they're made from fermented corn a lot of the time, and so again they can be high in histamine. So look at natural sources of vitamin C, and things like acerola cherry powder, for example. They're very high in vitamin C, and some people tolerate those very well. So thinking about getting your vitamin C from some natural sources. And also sugar. Sugar is transported into our cells via the same mechanism as vitamin C. So the more sugar we're eating, that takes up all the seats on the bus, if you like, and there's no seats left for the vitamin C. So the vitamin C can't get into our cells when we're eating a lot of sugar. So we want to be not eating so much sugar in order for the vitamin C to be able to do its job. And also when we're very stressed, we wee out vitamin C as part of our stress response. So if you are under a lot of stress, we need to take that into account and increase our vitamin C consumption to make up for the fact that we'll be losing vitamin C. Zinc is another one that's really important for our immune system. It helps the enzymes that break down viral and bacterial proteins and so kills them. And there's been studies that show that when people who have got high levels of zinc, cuts the length of a cold and increases the activity of immune cells so that we're sick for less time, we recover quicker, and it's also involved in reducing inflammation. So cashew nuts, chickpeas, pumpkin seeds, spinach, and cocoa beans as well. They're very rich in zinc. So again, if you're struggling with dietary restrictions, think about if there's anything in your safe foods that contain zinc and make sure you're eating some of that. Iron, similarly, is really essential for our immune cells to be regenerated, basically, for the proliferation, for the creation of immune cells, particularly those T and B cells, and producing the enzymes that we need in our immune system to function properly. And if we've got things like anemia and we've not got enough iron, then our immune system, it doesn't work as well, and we're much more susceptible to infections. So red meat, poultry again, and beans and lentils, pulses, they're all good sources of iron. So again, thinking about what you can eat that might improve your iron levels. Vitamin D, very important. We've already mentioned that it's essential for the immune system, and many of us living in the Western Hemisphere, particularly in the winter, we're not getting the sunshine and we can be deficient in vitamin D, and it's essential for both the innate and the adaptive responses. So we need to be increasing our vitamin D, particularly people with fibromyalgia. Interestingly, there have been studies that show there's a correlation between not enough vitamin D and having, the symptoms of fibromyalgia. So sunlight exposure is the best way to get it, at least 15 minutes of sunlight on our bare skin every day. Fatty fish like salmon and mackerel and herring, egg yolks, dairy yogurts, liver and mushrooms, they all contain vitamin D. But again, that's one of the ones that you might want to work with a practitioner to get a supplement on board, because, it's a really important thing to have, and it can be challenging to get enough of it through food alone. Garlic contains sulfur, which is essential for our immune systems to be able to attack viruses like colds and flu. So garlic is a good one if you can tolerate it. One study, 146 healthy volunteers given garlic supplements or a placebo for 3 months, and the garlic group had 63% lower risk of getting a cold. And another study found that people who ate garlic had much less cold and flu than the placebo group, and their colds and flus were much shorter. Again, it reduces the amount of time that you're sick for. But when you're eating garlic, it's worth bearing in mind that when we heat it, those beneficial sulfur compounds and the things in it are deactivated. So it's a good idea to eat it raw if you can. And also, well, if we crush the garlic and leave it to stand for 10 minutes before cooking, that can help protect those medicinal properties that are within it. So thinking about how you're preparing it, prepare it a bit earlier and leave it to stand before you cook it. And then supporting the immune system, manuka honey. So Manuka bush is this lovely flower that grows in New Zealand, and Manuka honey is the honey that bees have made from the pollen of the Manuka flowers, and it contains this substance. I'm probably not going to try and pronounce it because I don't think I'll get it right. Methyl glycoloxyl. Not sure that's correct, but it's got very strong antibacterial properties. So it's helping the immune system. It's killing off some of that pathogen load that then takes some of the burden off the immune system, so there's less for it to fight. And also the studies show that the Manuka honey can stimulate the production of cytokines that help us to fight infection. So it's supporting the immune system and boosting it at the same time. So that's why Manuka honey is particularly good, because it works on 2 levels. And then ginger, again, very anti-inflammatory, very antioxidant and antimicrobial. So it will be helping to kill off the virus if you've got a cold or a flu. and your immune system is battling but overwhelmed, the ginger will just help to kill off some of the pathogens so that your immune system has got less to do. And it also helps to regulate inflammation and reduce inflammation. So that makes the immune system work better. If we have too much inflammation, chronic inflammation, the immune system's not working as well. And also there's anti-cancer properties in ginger. So there's a study there that fresh ginger had antiviral effects against the virus that causes respiratory infections and helps boost the immune response against respiratory infections. Licorice root contains glycyrrhizin, which is a particular compound that is incredibly antiviral in studies, and there have been studies that show that it's active against COVID-19. So it's worth considering if you can tolerate licorice root, and we're not talking about Bertie Bassett's licorice sweets here, unfortunately. We're talking about what's on the screen there. It looks like wood. It's roots of the licorice plant, and you can get it in powdered form or like it's shown there in little chips, and you can make a tea with it. You pour boiling water on it and let it to steep, and then you drink that, and you can get all of the benefits of the licorice root. It's very strongly, again, antioxidant and anti-inflammatory, particularly good again for respiratory infections, so colds and flus, and as I say, COVID, it's a good one to try if you can tolerate it. And then elderberry, there's been several studies that show elderberry shortens the duration again of a flu up to 4 days compared to the placebo potentially. So it's very high in vitamin C, so you're getting that boost to the immune system and the antioxidants that help protect our immune cells. And it's got very strong antibacterial effects. It boosts the amount of white blood cells and can even, in some studies, they're showing that it might affect the way our cancer cells grow. So elderberry is a really good option if you can tolerate it. Adding in elderberry to your winter regime can help to promote your immune system and support you. Just a caution there that if you freshly pick raw elderberries, it does contain cyanide, very, very tiny amounts, but you don't want to be consuming a lot of elderberries in their raw state, particularly children and pregnant women. And if you're breastfeeding, for example, just be cautious, with raw elderberries. It won't hurt you to just eat a little bit, but you don't want to be, going mad and eating bucket loads of them. Interestingly, you may not think about this in terms of your immune system, but meditation, actually, there have been studies that show that people who meditate increase the production of antibodies in the body and increase our immune cells. So a study by the University of Florida there found 8 days of intense meditation caused a robust activation of the immune system. Other studies show that when you practice mindfulness and meditation regularly, it lowers inflammation. So specific markers of inflammation, the CRP levels in the blood go down. Compassion practices, which is part of a meditation practice, incorporating self-compassion and compassion for others, those in particular have reduced levels of inflammatory markers and also boosted antibody production. A Harvard study called the Mother Teresa effect, they did a study where people watched Mother Teresa doing acts of compassion. So they weren't doing the compassion, they were watching her being compassionate. And after they'd watched that, they had increased levels of IgA antibodies in their saliva. So their immune system was upregulated and they were producing antibodies in their saliva to fight off infections. So compassion and meditation are actually very powerful tools in supporting our immune system. So building those in regularly into your daily practice can actually help support your immune system, as can this practice of forest bathing, Shinrin Yoku, they call it in Japan. And it's an idea of going into the forest and immersing ourselves in the forest. And this is actually backed by science because the trees are emitting something called phytoncides, because as part of their own defense against infections that they don't want, they're releasing into the air these phytoncides, which comes from the Greek word phyton for plant, and side means to kill, so plant killers basically. And they're in the air when we walk in the woods, and they boost our immune system. So studies have shown that after we've walked in the woods and breathed in these phytoncides, It increases the activity and the number of our natural killer cells. So they are the ones that go round and kill off the cells that have become infected with anything or that might be becoming cancerous. That's their job, and they get boosted. And they also have antimicrobial effects. So again, they're doing that job of the immune system for us. They're killing off nasty bacteria and viruses and fungal infections. They've got antimicrobial properties, apenine and limonene in the air that we're breathing in will be killing off pathogens in the body. So again, something else that you might not think about, and this is really valuable if you are struggling with your diet and you're struggling to get on board all those nutrients we talked about. There are other ways that we can boost our immune system that don't involve eating anything, like walking in the forest, for example, or meditating or doing compassion practice. And then finally, supporting the immune system. There's a lot of really good research about far infrared light. Now, you might have heard it called far infrared sauna, but actually that's missing the point because it's not the heat that's doing the work. It's the light. Far infrared is a light frequency. It's invisible to our eyes, but it is actually emitting light when we have a sauna, a far infrared sauna. And it's been found in studies to increase our core body temperature. Obviously, it's doing that work, and that's going to help our immune system fight infections by increasing our temperature. But it also stimulates the production of the white blood cells, those lymphocytes. It can help with reducing inflammation, so modulating the immune response and making sure that it doesn't go too crazy and we don't get that chronic inflammation. It boosts our circulation, which obviously means that our cells are getting the nutrients and the oxygen that they need, which helps our immune system. And it also triggers a parasympathetic nervous state, which is similar to the state of meditation and mindfulness. It puts us in the opposite state of being stressed. It puts us into that rest and digest state, which obviously enables the immune system to switch on. When we're stressed, our immune system switches off. When we're in the parasympathetic, when we're relaxed, our immune system is functioning optimally. So far infrared light, again, another non-invasive, non-food way of increasing your immune system activity. You do need to go very low and slow to begin with, really gentle if you try this, literally 30 seconds to a minute with if you've got MCAS and you're really sensitive. But it's another way that we can, another tool that we can use to support our immune system. So I'm going to leave you on this slide with some natural first aid remedies. If you want to put together a first aid box, if you are, one of these people like me that struggles with drugs and with pharmaceuticals and your MCAS doesn't really like them a lot, it might be worth exploring using natural things with the proviso that obviously, as I said, just because it's natural doesn't mean that we won't react to it. So we do have to do some careful testing here and make sure that we don't react to it, and do testing, very tiny exposure to begin with, just to see how we react. But if you can find some of these to have in your toolbox, it's possible to build up a natural first aid kit that can support your body and help promote health, and that we can use as first aid. So for example, mild skin infections, oregano oil is very strongly antibacterial. If we've got sore skin and skin rashes, calendula cream is absolutely fantastic for that. Very gentle, very soothing and healing. Cuts and grazes, witch hazel can be helpful. Again, it's antibacterial. If we're struggling with insomnia, chamomile tea and an Epsom salt bath. Again, for some of us with MCAS, you might need to start with a foot bath and go really, really gently and really slow. Tiny amounts of this, remember, always go very tiny and build up. Coughs and colds, ginger tea and chicken soup, it's traditional, but actually studies are showing that chicken soup does contain properties that help support the immune system with a cold. So fever, we mentioned earlier, yarrow tea and elderflower tea. Minor burns, I have an aloe vera plant. If you could see behind me, I've got my curtains drawn, but we've got an enormous aloe vera plant that we grew from a little tiny thing. They grow so quickly, and you can just cut off a piece of the aloe vera and rub the gel that comes out of it onto a burn. It's fantastic. It immediately takes off the pain and helps the burn to heal. So I really recommend everybody grows an aloe vera plant if you tolerate it. Obviously, some people don't, but it is helpful for lots of things. Insect bites, peppermint oil is very helpful to stop the itching. I personally can't tolerate peppermint, which is what I'm saying here. You know, for me, that wouldn't be any good, but I probably use the aloe vera or the calendula. Again, a tummy upset, peppermint oil. Apple sauce is really good if you can tolerate apples. So cooking apples into a kind of sauce. Rice, banana, apple cider vinegar, they can all help with an upset tummy. But again, choose the ones that you can tolerate. And antihistamines, nettle tea is a really good natural antihistamine source. There are lots of other natural antihistamines and mast cell stabilizers that we can use. So it's worth thinking about natural alternatives because they are effective and they help support the body, whereas pharmaceuticals sometimes are suppressing what our natural immune system is trying to do. The natural, plants and these kind of remedies, they work with the body and support the body. So that's a helpful way of looking at it. So those are my contact details. My email is livewellwithchronicillness@outlook.com. So I think we're nearly up to time. There's 5 minutes, so I'll just take a few questions. But if you do have anything that you want to ask and you want to email me, then I'm happy for you to do that.